Hey, welcome to Lessons with Mr. Clark. Today we're going to be talking about divisibility. It's going to set us up for division. Let me give you a joke here. Why did the little boy wear glasses to math class? Because it improves division. All right, so divisibility. What does it mean to be divisible? To be divisible by means you can divide evenly. Your answer is a whole number with no remainder. So your answer is a whole number. There is no remainder. I'm putting that in parentheses. Okay, so here are 56 blocks here. Okay, you could count them all. 10, 20, 30, 40, 56. Okay, so if we're going to divide this into 4 groups of blocks, which it's already done for us, we have 56 divided by 4 gave us, we can see there's 14 in each one. There are no remainders. Okay. Conversely, over here we have 63 blocks. Again, we divided them. You can trust me, there's 63. You don't have to count them all. We can divide them into 4 groups, but now when we divide them into 4 groups, each group has 15, but then we have 3 remainders. These 3 are left over. We're not going to chop those up and give them to these 4 people. You can do that. We can do fractions and decimals, but right now we're just going to say 63 divided by 4. Well, 63 divided by 4 equals 5 with a remainder of 3. Okay, we can write division several different ways. We have the classic way, 63 divided by 4, or 56 divided by 14. We can also write it as 63 over 4 as a fraction. A fraction bar, look at it, it's actually just a division symbol with numbers for dots. Whoa, just blew your mind. That's another way we can write division. We could also write it, computers a lot of times write it like that. Or if we're going to write it long division wise, we write it like that. All different ways to write division. Okay, let's go over some rules for divisibility, some shortcuts that can help us out to know if numbers are divisible or not. The easiest one is the divisibility rule for the number 2. A number is divisible by 2 if it is even. All even numbers. To be even, that just means it ends with a 2, 4, 6, 8, or a 0. In the ones digit, there's a 2, 4, 6, 8, or 0. Okay, so let's do a couple examples of this. 52. Well, in the one digit, there's a 2, so yep. How about the number 71? In the one digit, there's a 1, so nope. How about the number 1234? In the ones digit, there's a 4, so yes. So even numbers are divisible by 2. Odd numbers are not. Okay, let's go over divisibility rules of 5. If it's divisible by 5, it ends with a 5 or a 0. And you know that just by counting 5, 10, 15, 20, 25, 30, 35, 40, all the way up. So let's look at the number 105. In the ones digit, there's a 5, so yep, that works. How about the number 2033? In the one digit, there's a 3, so nope, that does not work. What would the next biggest one be after 2033? Yep, you're right, 2035, because it ends with a 5. So those are some examples. Okay, next, divisibility rules for 10. Super simple. If in the ones digit, there's a 0. It ends with the 0. Any number that ends with the 0 in the ones digit. So the number 50, yep. The number 5,000,002, Nope. The number, I don't know. We could just write all kinds of digits, and as long as it ends with a 0, it works. Okay, that's 2, 5, and 10. Okay, let's look at 3 and 9 now. These might be new to you. 2, 5, and 10 should hopefully be revealed. The number 3 is any number where when you find the sum of the digits, that is divisible by 3. Okay. The sum of the digits is divisible by 3. So we're just going to add up all the digits. Sum means add. So the number 351. Okay, so 351. We're going to add each digit. Seems counterintuitive. We don't do this much in math. We're going to do 3 plus 5 plus 1. 3 plus 5 is 8, plus 1 is 9. Is 9 divisible by 3? Yes. So 351 is divisible by 3. I could explain to you how it works, but we're not going to take the time to do that. How about the number 445? Okay, so we'll add those. 4 plus 4 plus 5. That adds up to 13. Is that divisible by 3? Nope. So 445 is not an example. Okay. Let's go with 1,111,113. Okay. So we're going to add all those digits. 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 3. So they all add up to 9. Is that divisible by 3? Yep. So that works. Crazy stuff. Okay, let's look at the divisibility rule for 9 now. It's exactly the same, except now with 9. Okay, so the rules for 9. We can just write down the same rules we just wrote down for 3, but by 9 now. The sum of the digits is divisible by 9. Okay, so we have the number, let's just take 81. You already know that. But in 81, 8 plus 1 equals 9. So yep, that works. How about the number 181? 1 plus 8 plus 1 is 10. Nope, that's not divisible. How about the number 999,963? Okay, so we want to add up all these digits. 9 plus 9 is 18, plus 9 is 27, plus 9 is 36, plus 6 is 42, plus 3 is 45. We add them all up, they all add up to 45. Is 45 divisible by 9? Yes, sir. 9 times 5. So that works. All right, some crazy new rules to add to your repertoire. We could come up with a rule for 4 too. I'll just tell it to you if you want to know it. But this is not one you'll have to put in your notes. The divisibility rule for 4 it's a little different. It's the last 2 digits are divisible by 4. So any number, and again, you don't have to add this to your notes. The number 625, we take the last 2 digits, if that's divisible by 4. That one's not. Number 624, the last 2 digits, is divisible by 4, so that would work. But that's just an extra insider hint. All right, so in conclusion, today we learned some divisibility rules. We learned what divisibility is. Thanks for joining in. Have a great day.